Here we are at our 4.3 factoring where a is equal to one set of notes. Now we're asked to factor quadratic trinomials when it's in standard form. And here it is, ax squared plus bx plus c, where a is equal to 1. So in the past, what we've done is we've factored a GCF, a greatest common factor. And I really want to just take a moment and go back to, you recall, y equals mx plus b. Okay, now right here we have the first degree as our exponent there, and where standard form really starts to come up is, imagine then you have still that kind of y equals mx plus b, but I'm going to change those variables to bx plus c, and then I'm going to go ahead and add ax squared to it. And thus, we have something more of a standard form for those trinomials. Okay? And trinomials, we just mean that they have three terms here. And so that's really, it's almost like taking y equals mx plus b and expanding it more onto that first term. Okay? And so that's kind of the idea here, is we're taking almost that y equals mx plus b and expanding more upon it. All right? So that, again, though, that's kind of where this a, b, and c are kind of coming from for your polynomials. Now, again, though, it's a quadratic, a little bit more of a specific type of polynomial. Now, when we're talking about example 1, in terms of factoring, what you can really identify, factoring is the same thing as really just anti-distributing. And we kind of saw that in our previous set of notes. Comparing the two, when you're distributing versus factoring, that's really the opposite of one another. And so anytime you hear the word factoring, you're kind of almost thinking in the back of your mind anti-distribute. Now, the difficulty in this is when you're talking about trinomials, it kind of takes on a certain form. Sometimes you can pull out a GCF, and sometimes you can't. It really just depends on the situation that you're presented with. But for today, what we're going to do is just focus on when a is equal to 1. Okay, just specifically those cases. And again, with factoring, there are really different strategies with it. We're going to talk about all the strategies. But for today, we're just going to talk about when a itself is equal to 1. Okay? And when we're talking about standard form, y equals ax squared plus bx plus c, this first term here is 1, okay? The moment it's not 1, things start to change up a little bit, but for today, we're just going to say where a is 1. And you'll definitely see these in the future, where a is 1. Now, for example 1, we have x squared plus 7x plus 10, okay? Now, what I always advise is for our c term, we're going to create a small list of factors. So, in other words, in the back of our minds, we're starting to think to ourselves, what times what gives us 10? Well, 1 times 10 definitely gives us that 10. And then we're going to start to think about what other two numbers can multiply to give me 10. 2 and 5 also give us 10. Is there anything else that can multiply to give us 10? And the answer is no. That's pretty much it. That's the end of our list for two numbers that multiply to give us 10. Now, when we see these trinomials, instead of pulling out a common number like a GCF, well, we would almost try to do x, but this last term right here, unfortunately, doesn't have an x to be able to give. And so, as a result, then we're going to factor two binomials from this trinomial. And what that looks like is you have these two parentheses, and then what times what gives us this first x squared? Well, x times x does that. Okay, so that's going to be your first set of values inside of your parentheses. Now, this becomes a little bit more of the challenge. We have to ask ourselves, which of these two pair, either this 1 and 10 or this 2 and 5, when we combine them, we know that they're going to multiply to give us 10. But when we combine them, are going to give us this regular 7. Well, 1 and 10 when we combine those, can give us either two options. They can give us 9 or 11, and in no way can they combine to give us 7. On the other hand, 2 and 5, we know that we can get a 7. They can also combine to give us like 3, depending on negatives, but they can at least give us that 7 in the middle that we're hoping for. And as a result, knowing that, then we're going to go ahead and use the 2 and the 5 from our list. So we have 2 and 5. For right now, the order doesn't really matter. And everything in here from our original question is positive, so as a result, everything is going to go ahead and be positive. Now, what I always advise students, especially as they're first learning this, is to go ahead and distribute just to make sure that what they've factored is correct. So what I mean by that is x times x gives us x squared. X times 5 gives us positive 5x. 2 times x gives us positive 2x. And 2 times 5 gives us positive 10. And then we know that we can go ahead and combine these in the middle and get positive 7x plus 10. Okay, so it's a nice, just fantastic way to check and see, hey, did we get this correct or not? So this x plus 2 times x plus 5 is actually our factored form for that expression. All right. Now, let's go ahead and check out number 2. Again, a is 1, so pretty much when a is 1, you can almost immediately just go ahead and do your x and x. Also, you're going to go ahead and create your list for this c value. So in other words, what times what gives us 20? Well, 1 times 20 does that. Don't forget that. Some students, they just they don't forget it. They just don't think about it as much. So always just think 1 and that number can give you that value. And sometimes that's the case. 2 and 10 also gives you 20. 3, no. 3 is not evenly divisible by 20, so he's out. 4 and 5 is also evenly divisible. And the moment, a little bit of a strategy, the moment you start to see where these numbers start to come together, you're really close to completing your list. So in other words, if I did 5 and 4, well, that's kind of a duplicate of already that set of factors. So we really don't even need it at all. So we can kind of get rid of them. So that is, again, our list of factors. It really doesn't matter for the list which order they're in. I encourage you guys to pretty much just go down the list, though, so that you can kind of keep things straight. But now, our goal is to think about which pair here, either this one, or this one, combine in any way, doesn't matter positive or negative, to give us this positive 21 in the middle. Well, 1 and 21 do that. And as a result, those are the numbers we're going to use. So we have 1 and 20. And since everything is positive in here, everything is going to be positive. So that is your factored form. Next up, and again, you can distribute. I always encourage that. So x times x is x squared. X times 20 is positive 20x plus 1x. Plus 21. I'm sorry, plus 20 rather. 1 times 20 is 20. And then we combine these together to get that 21x in the middle. So you can see you get your original. Our final answer, though, the factored form is this guy right here. That x plus 1 times x plus 20. For our next question, we have k squared minus 10k plus 25. Well, again, a is 1, so for right now, we have just k and k. And we're creating our list for 25. So that's 1 and 25. And 5 times 5 gives us that. And unfortunately, no other values give us that 25 that we're hoping for. And what we need to do is combine to give us negative 10. So we have to ask ourselves, what times what gives us negative 10? I'm sorry, what plus what should give us negative 10? Well, at best, this can give us 24 or 26. Whereas this can give us 10 or 0, combining them in any way. Positive, negative, doesn't matter. And as a result, since we're looking for a negative 10, we know that we have to use a 5 and 5 there because that gives us our number 10. So we're going to use 5 and 5. Now, if everything was positive, then we'd end up with a positive 10 in the middle. And unfortunately, what we need is a negative 10. That sign matters. And consequently, what we're going to do is we're going to make both of these a negative 5. Now, what we can do is always, again, check this just to make sure we factored it correctly. So k times k is k squared. K times negative 5 is negative 5k. And negative 5 times positive k is negative 5k. And negative 5 times negative 5 is that positive 25. Well, lo and behold, in the middle, since they're both negative 5k, we end up then, when we combine them, to get us a negative 10k. And then all the other stuff, since it can't be combined, just drops down. And thus, we get our original. So that's a good sign. And there is then our solution for that. K minus 5 times k minus 5. Now, a lot of teachers, just FYI, in the future, really want you to kind of simplify that further. So what that would look like then is k minus 5 squared. Okay. Similarly, if I gave you like 5 times 5, you know that you can represent that as 5 squared. That's kind of the same idea that's happening here. You have k minus 5 times another k minus 5. You just represent that as k minus 5 squared. For number 4, we're going to go ahead and factor this. Since a is 1, we have our q and our q in this case instead of in our first set of binomials. Creating our list for the number 36. We have 1 and 36. We have 2, it's evenly divisible by, and 18. We have 3, it's evenly divisible by 12. We have 4 and 9. And we also have 6 and 6. Now that is the extent of our list for that number 36. And we have to, again, always ask ourselves, what times what gives us, in any combination, that negative 15 that we're hoping for? Well, 1 and 36 don't do that. At best, you can get to like 35 or 37. 2 and 18, close. That would get you to 16, but not quite there. Whereas 3 and 12 can definitely get you there. In all the other numbers, they unfortunately cannot. So 3 and 12 are our values that we're going to go ahead and use. Now, as you learn some of the tools when you're in terms of factoring trinomials, you're going to recognize some patterns here. And one of those patterns is, notice how a is positive, this 1, and this middle term right here is negative. And the last one is positive. Anytime you start to see that pattern, you know that when you factor these, it's going to have to be a negative and a negative. Okay? And to kind of help illustrate that, we can go ahead and distribute just to kind of help justify why that's the case. So q times q, we know that we get our q squared. Lo and behold, we had that originally. So that's not too much to think about. Q times negative 12 is negative 12q. Negative 3 times positive q, we get a negative 3q. And lo and behold, that we get our negative 15q in the middle that we needed. So that's a good sign. And then finally, lastly, when we multiply negative 3 times a negative 12, we get our positive 36. Okay? And so that's really why you have that where it's negative in the middle but positive at the end. You kind of, in the back of your mind, really know then that it's going to be a negative when you factor it. Okay? Again, it's not like 100% guarantee just based upon what this a term is, but like literally 95% of the time you can kind of anticipate that. Next up, we have our m squared plus 8m minus 20. Again, same idea. We're going to have our m times m in our parentheses. And then we do ask for the list for that C term. So the list for 20. So we know 1 and 20 do that. 2 times 10 also give us 20. Unfortunately, 3 is not, but 4 is. 4 and 5. And again, since these two numbers are really close to one another, usually we're pretty close to the end of our list without duplicating. Now, we have to ask ourselves which of these pair kind of give us that positive 8 term that we're hoping for. And 1 and 20 don't do that. 2 and 10 do, though. So we're going to go ahead and use 2 and 10 as our values. Now, this is where we really have to start to kind of play with the signs a little bit. And what I always encourage my students is kind of just distribute it like you would normally check anyway, and then see what the values you need comes out to be. So what I mean by that is m times m is m squared. Well, we kind of already knew that we needed that. M times 10 is a 10m, right? And then when we distribute the 2 times m, we get a 2m. And then finally, 2 times 10 is 20. Now, here's the thing. What we need is a positive, right here, 8m, okay? Now, looking at the two values that are going to be combined to get that m, which one needs to be positive and maybe which one needs to be negative to get that normal positive 8m in the middle? Positive 10m needs to be that. So we're going to make him positive, we're going to make him negative to get that 8m when they combine together. Now, kind of working your way backwards, which one of those signs needs to be negative and which one needs to be positive? Well, the 10m needed to be positive, so we're going to go ahead and put a positive in that binomial, versus the negative 2m needed to be negative to get that value. And then, as a result, what you end up then with is that m times m is m squared. M times 10 is that positive 10m. Negative 2 times m gives you that negative 2m that you need to combine to give you that 8m. And then finally, negative 2 times positive negative 2 times positive 10 gives us that negative 20. And as a result, which again, you need that negative 20 at the end, that is your factored form. I know there's a ton of colors on this screen. I'm trying to differentiate it so you can see all the little steps, but there it is. It is m minus 2 times m plus 10. So you're using your list to kind of help you figure out the numbers that you need, and then you're kind of playing with the signs to figure out what two numbers or negatives and positives combine to give you this negative or positive term in the middle. Okay? So let's see one more very similar to that style question. We've got y squared minus y minus 56. Well, we've got y times y because a is 1. And then, again, you're still going to create your list for this number 56. So you have your list for the number 56 is 1 and 56. You have 2 and 28. You have, unfortunately, it is not divisible by 3. It is divisible by 4, though. So that would be 4. And let's see here, that would be 48, and then 52, and then 56. So that should be 14, I want to say. Yes, 14. And then it is not divisible by 5. It is not divisible by 6. You could do 7 and 8. And since those numbers are really close to one another, that would be the extent of your list. Now, you have to ask yourself which of these pairs combine to give us a negative 1 in the middle that you need? Well, 7 and 8 is clearly the front runner there. So we're going to go ahead and place our numbers there. 7 and 8. Doesn't matter about the order right now. And then what we need to go ahead and do is figure out, what does the sign have to be? Well, I know y times 8 is going to give me an 8y. And I know when I do my kind of inner multiplication, that is 7y. Well, which of those two, or what do the signs have to be such that you get this negative 1y in the middle? Well, that would force 8 to be a negative and this 7 to be a positive to get that negative 1. And kind of, again, working your way backwards, there's your negative and there's your positive to kind of create that situation. And you can always, again, distribute these, get your y squared. There's your negative 8y right here. There's your positive 7y right there. And 7 times negative 8 is negative 56. And again, that was from our original. So that is our factored form, y plus 7 times y minus 8. So again, though, this is our 4.3 set of notes, factoring, where we're not really using a GCF, but rather taking our trinomial and breaking them down into these two binomials. This is a skill you really need to know, guys, okay? Miss Mason and myself, we're going to continue to hammer this just because it is literally that crucial that you guys know going into high school. But again, though, that is our 4.3 set of notes.